Want to turn this into that? Let me show you audio super resolution using OpenVINO Audacity plugin on my AI PC. Core Ultra processor has 3 engines, a CPU, a GPU, and an NPU. Putting these 3 engines to work means getting the most out of your machine. OpenVINO is a great deployment package that does exactly that. And Audacity is a free and open source digital audio editor and recording application software that has an OpenVINO plugin to execute some very useful audio features. Please check my other video on using the OpenVINO Audacity plugin to clean noise, to separate channels, and to even generate music. Links below. Super resolution. First, how does image super resolution work? Basically, if you have an image and you are presenting it in lower resolution, so much fewer pixels, but on the same size, it means that your pixels are much bigger or that there are spaces between the pixels. There are ways to complete these spaces, basically all kinds of interpolations. On the right, you can see bicubic upscaling, for example. The problem is that once you downsized the image and used less pixels, you lost data. Data that cannot be fully recovered unless you have some knowledge of the image. That knowledge could be a model that was trained to upscale images. A model that was trained using many low-resolution cat images as an input and their corresponding high-resolution images as the output or target, for example. But how is this related to music? Well, here is a simple sine wave and its representation in the frequency domain. And the rest of the audio is a sine wave of a higher frequency and the representation in the frequency domain. The problem is that from the time domain, it is not clear what the frequencies are, and using only the frequency domain, it is not clear which sine wave comes first. You lost the time knowledge. So we're using a spectrogram to basically show both the time and the frequency. And here is your image. A low-resolution audio
The Hebrews, it was
looks like that, and the high-resolution version
The Hebrews, it was a token.
looks like that. So all we need to do is train a model to start from low-resolution spectrograms and produce high-resolution ones. Let's try Audacity Super Resolution. Look for the OpenVINO plugin to Audacity. Few options, link below. Installation. You will need Audacity 3.7.1 at least. Just install it, don't remove any older version. And then install the OpenVINO plugin and enable it. I'll take a very low quality audio that sounds like that. Select a track, effect, OpenVINO effects, super resolution. My models are already loaded, don't unload. If you're using speech only, select speech model, and OpenVINO allows me to run each of these 3 models on a different device, CPU, GPU, or NPU, and it's running. The heavier model is the DDPM, sort of the equivalent to UNet model used in Stable Diffusion. Let me arrange the waves, and we just managed to turn these into these. Easy to see the differences. Let me arrange them on the same scale and present the spectrogram. You can see how the original had only low frequencies and how the super resolution audio is all across the spectrum. Pretty cool. Audio, super resolution, super fully utilizing your AI PC, CPU, GPU, and NPU, super using OpenVINO and Audacity. Try it out. Subscribe. Thank you.